Hi everyone, my name is Michael. I was here last October with my friend Steven for going over an introduction into PowerShell as it relates to information security. So this is part of a series of talks we wanted to have where we first looked at the history of PowerShell and how it relates to security, essentially what allows it to be used for use in attack chains or kill chains. And so what wanted to go over today is going to be some of the implementations. We'll be looking specifically at PowerShell Empire as well as some of the Nishang tools, and then kind of going to how those relate into the kill chain or attack chain process. So kicking this off, we've got overall we'll just kind of discuss offensive PowerShell, or why look at PowerShell offensively and why is it that bad actors would like to use PowerShell. And then going more into the focus on PowerShell Empire and its implementation. So we will be looking at not only its fundamentals, how it can be used for enumeration, where it can be used for privilege escalation, lateral movement, persistence, and then post-exploitation as well, both through PowerSploit, PowerUp. There's a few actual different modules available to it, but plenty that could make PowerShell a lot scarier than what people think it is. Then we'll look at Nishang, and this is going to be a little bit of highlighting what we had spoken on previously, but looking at where it can be used for the same things: backdoors, priv-esc, enumeration, and something that they refer to as PowerPritter. Those of you familiar with MSF, interpreter, so clearly a play off of there. And then why I'm a fan of PowerShell Empire, and then concluding with why I don't think PowerShell Empire will ever have the sunset on it, at least as long as Windows continues using it. So just starting off with a quote from Jeffrey Snover: "Teach a man to light a fire and he's warm for a day. Set a man on fire and he's warm for the rest of his life." So I'm a huge fan of the Shell Father. You'll see a lot of random quotes from him throughout this presentation. The subtitle for this, just to kind of go back, was "When in doubt, run in circles, scream and shout." Another lovely Jeffrey Snoverism. The big thing with PowerShell is that it's so versatile as well as accessible, which allows it to be used in a variety of different ways. And not only that, but it tends to be fairly agnostic nowadays. Even within Windows, you're not isolated to just using PowerShell. You can put command line in there, Python, for the most part, a lot of other languages, but you may have to customize it a bit further. Here, what's scary is that your bad actors don't need to be PowerShell experts to utilize this in an offensive capacity. And that's what makes it fairly scary. What's unfortunate is that it itself isn't intended for malicious use. However, it's ripe for being used maliciously because of what it's capable of. So kind of starting here, we'll look at, so overall, these topics are essentially what's officially defined by Lockheed Martin as part of the cyber attack chain, cyber kill chain. So just starting at the top, reconnaissance, we understand that for being your information gathering, how it is you're going to understand what could be exploitable in an environment. Weaponization, this is where how do you then use that information you've previously gathered for applying it for exploitation. Delivery, how do you get your solution onto the target system. Exploitation, making sure that you can exploit it the way you would think it would be exploited. Installation, this would be if you have anything else as a part of your package or payload that would allow it to be, that would give you additional functionality. Maybe you want continual persistence, maybe you've built a Trojan. You've got a few different options. Command and control, of course, for how it is you'll be orchestrating this once you have everything fully accessible. And then actions on objectives. Decided to put another Jeffrey Snover quote in there. "The only difference between BitLocker and ransomware is whether you have to buy the recovery key." And that's fairly true if you consider that just through PowerShell alone, you can manage all of BitLocker, at least in an environment. And consider what that would mean if a bad actor has access to something like that. So we go into the topic of why exploit using PowerShell. And this is a fascinating topic because PowerShell, from our previous talk, we were talking about the history of PowerShell, where it is it's currently used, particularly throughout DevOps and DevSecOps, and how it's continued to evolve. One of the biggest challenges of PowerShell, which we had highlighted before, is that PowerShell continues maintaining its legacy code while still introducing new features. The biggest concern there is that going back through previous versions of PowerShell, you're now able to access pieces of Windows or part of Windows in an environment that you normally shouldn't be able to access, and not through regular means. So this is where there's a challenge, because existing DevOps processes may rely on some of these legacy PowerShell functions. So how do you find the balance between that? This is something that's ripe for exploitation by bad actors, because it's a native Windows administration resource. Bad actors can now use the same exact tools a system admin might use for running through an environment, running through a Windows environment, and causing some mayhem. Consider that remoting is a standard feature in PowerShell, at least nowadays. So meaning the bad actor doesn't even have to be physically present, let alone with physical access with the network in person. Persistence. PowerShell allows session persistence throughout, especially through remoting. It's a common part of maintaining an environment as well. And so going on into logging and then obfuscation. All of this would equip a bad actor with a lot more knowledge than what they typically would have. And if they know enough to piece those tools together, they can do some serious mayhem. You don't need additional libraries or binaries. So something that's fairly common, look at Meterpreter, or look at the MSF rather. Within that framework, you always have new modules coming out and being released, but for the most part, you still have to go out, add additional tools. If you're going to do things from scratch, you may need access to libraries that aren't part of your standard command and control environment. And then lastly, PowerShell is a scripting language capable of working with other languages. This gives it the flexibility that a bad actor may want for doing more dangerous things with it. So kind of going into what's described in this was a quick thing I drew up earlier today. So as you can see, within PowerShell, I put something encoded in base64. What that is, unsure. If you take a look below, this would be a sample of how it is a bad actor may want to execute this. This is not the exact implementation because I'm doing this from within a PowerShell console, but let's say you had access to a reverse shell of some sort. Maybe from that you have access to command line. It wouldn't take much for you to encapsulate what I have here in this command as something that could be run in that. So let's look at what happens next. So let's take a look at some of the arguments here. And I'm calling these scary arguments for a few reasons, where first we take a look at no profile. And what no profile will do is that it allows the PowerShell script to be run without any profile context underneath it, meaning it's not held to a particular profile regardless of how this is being accessed. Non-interactive. This makes it so that you don't need users to interact with this in any way whatsoever. We go into Windows style hidden. This makes it so that the whole PowerShell prompt is completely hidden from your users. So they will never know that this is even something that will be running on their system. No exit. You need the session to maintain persistence. You want something to show that, or you want something where, let's say you have a listener and you want to be able to capture shells. You want to make sure no exit is active such that you have a means of maintaining that. We go into execution policy bypass. Execution policy is one of the most, it's necessary for PowerShell, but it's also annoying, especially because it can be bypassed so easily from a PowerShell command line. And what this really is doing is you're no longer restricted to the confines of the standard environment, the standard execution policy. This lets you completely avoid dealing with anything that would be there for limiting the scope of your actions. And then lastly, encoded command. So this goes back into this base64 encoded command I made. The fact that you have true obfuscation available to you, where this may still be accessible to whoever and it can be decoded. It's not as though it can't. But you do slow down would be researchers, anyone who's looking at trying to identify what are they trying to run on this machine. So to this, and just kind of more specific details, just going into what it is we were just describing. But what makes this fairly scary is that, yeah, you have no idea what's actually running there. This is the message I chose to put in there, but it goes to show you that you can pretty much encapsulate any PowerShell command possible. So to give an example, there's a common thing attackers will use, the invoke expressions, particularly invoking expressions so that you can download resources. Imagine that you'd be able to download a payload into your target device without the user being aware of the presence of that payload, meaning this will happen in the background. The user has no idea it's going on, unless maybe they're monitoring their network, looking for packets, anything incoming network activity. So one, PowerShell offers a lot of different ways for hiding your tracks, which makes it very enticing for bad actors. The fact that it itself isn't malicious inherently, because you can understand from a DevOps perspective why things like this might be desired. Maybe you're running critical functions or commands that you don't want the user ever to really see, something that hides what's going on in your DevOps processes for ensuring that security. And so in the same way DevOps and sysadmins may use it, bad actors would use it for exactly similar mentality. They want to be able to hide what it is they're doing, and if anything, trying to disguise it as though it's something intended to be run on that target. So going into essentially what will kick off all of this, PowerShell Empire. So PowerShell Empire is, it's one of my favorite PowerShell suites, at least from a perspective of what you can do from post-exploitation. So a lot of you may have used Kali in some sense, especially for trying to get into, if you're looking at penetration testing of any sort. Linux, for the most part, as it communicates with Windows, is great for a lot of things, but you may find yourself limited depending on how it is you're trying to get access to something. What PowerShell Empire does is that now that PowerShell is accessible to Linux environments, combined with Python, you get a full interface much like Meterpreter or any of the MSF tools. And you'll be able to then load PowerShell modules that you can then send through much like you would with any other penetration testing toolkit. It's a full framework that utilizes native Windows frameworks for use in attacks, penetration, recon, things that would be a common part of a kill chain. So looking at some of the fundamentals, and I do got a screenshot of what Empire would look like if you were to load it in a console. It's a PowerShell-driven post-exploitation agent capable of running PowerShell agents without needing PowerShell legacy. So consider that encoded command I had shown earlier. That doesn't require the existence of any payload on the target. All of that can be sent remotely as a command for execution on that target. The huge value here is that you can see how that's a minimal footprint, something that attackers want to utilize to hide their tracks. Then going into it's fully customizable. For those of you familiar with PowerShell and scripting within PowerShell, you know that building your own PowerShell modules is one of the best features of PowerShell, something where you want specific functionality in such a way and organized so it's not a huge mess. You can build your own PowerShell modules, your own PowerShell scripts, and have them incorporate with other functions as it pertains to your DevOps or system administration. Some of the common package and module types you'll find in PowerShell Empire: listeners, stagers, agents, logging, downloads, and modules and scripts. So listeners, for those unfamiliar with it, would be for how it is you'd be able to listen for a particular activity such that you can catch a reverse shell back. Stagers, this is a fairly broad group of packages within PowerShell Empire because depending on how it is you want to exploit your system, you've got a few different options here, and we'll go more into stagers later in the presentation. Agents, similarly, you may require an agent running on your target for getting things running. Logging, of course, you may be trying to use logging for triggers, making sure that you know a user is present, maybe looking for a particular IP address. And then downloads, this will be for your payload transfer, payload deliveries. So this is just a quick, if you were to run listeners inside of PowerShell Empire, you get a quick list of the different kinds of listeners you can have. So just take a look at the list right here going from underneath the name. Everything from kill date, staging key, you can have it listen for a particular type, redirects, you can add in a delay on your listener, particular hosts. These are essentially, you have different ways of customizing your listener such that it can respond to different triggers. You're not just looking for a different shell, but maybe you want it responding to a particular event. Same thing with particular profiles, who's using it, where it exists on the network. Even you may be trying to manipulate an administrative user, so then you want to isolate it to a particular user.
Is this listening on local host or can it be anywhere?
It can actually be anything. So much like what you see with Interpreter, you can set it to be any particular listener on any host with any defined port. So you can run multiples of these. You can't even have it try to catch other shells in a nested listening scenario. Well, no, you bring up a great point, because this goes into the whole obfuscation of it. And this is where PowerShell gets a little scary too, that you get so deep into it, you start placing things within variables and nesting it even further. The likelihood of that being discovered by a researcher or someone looking at analyzing, well, no, exactly. It's what makes this a common, so I didn't mention this at the start, but the world of advanced persistent threats, PowerShell Empire is a common tool they're seeing, or a common framework you're seeing applied through a variety of different methods. And what makes it so interesting is, for the most part, a lot of the actions it takes initially aren't things you would find to be that suspect. You have to dive in further to see what is it actually trying to do with this. And then the fact that I'll show some other pieces that make Empire even scarier. You have ways of hiding your tracks even further such that it doesn't look suspicious. And that's what makes it scary. You have to look at what the follow-up activity is to really identify that was the entry point for the scary activity. So we'll start with just enumeration, the reconnaissance piece, information gathering. From the host end, for situational awareness, within PowerShell Empire, you have a DNS server commandlet. This is, and I'll mention this, that as the second talk as a part of a series of talks, we do have a third and fourth talk we would like to give where we do a live demonstration within a common Active Directory environment where we do exploit it using Empire in these ways, with the last talk being a look under the hood for how it is these tools are doing what they're doing. So going back to situational awareness from the host perspective, you can use the DNS server tools for fully enumerating DNS servers on the host you're on. So meaning pull all the A records you can. If there's any associated IP addresses, you've now mapped out the network at least relative to that host. Computer details. The bigger thing here is going to be how it serves in logging and what you can do with event logs. So you can identify app logs. Maybe there's a particular app that's being run. You want to change something to that app being run such that you can hide your tracks further. PS scripts, maybe there's known PowerShell scripts being run. Maybe there's a potential way of exploiting one of those PowerShell scripts, especially if it's running on a timer. Saved RDP sessions. This will be known saved RDP sessions that the host views as relatively safe. So another point where attackers may consider looking at utilizing that for exploiting a system. Biggest thing with computer details is that it does require admin privileges, but it doesn't require high integrity access. So you can do this with, you don't need to be a domain admin, even local admin would be strong enough. One of the last pieces that's common with Empire is going to be Windows enumeration. And these are enumeration actions available without admin privileges. This is even scarier in that imagine what it is you could pull about an environment, especially from just a local machine and what it has access to. So these are just some of the pieces, but a lot of this would be enough for helping orchestrate and design an attack that would let you compromise a Windows environment. Going into, so we were looking at the host end of it, now taking a look at the networking end of it. We can run consistent ARP scans against some of our defined IPv4 addresses. So maybe we ran DNS server earlier. We now have some IPv4 addresses, or we're pretty certain those are the endpoints. Run ARP scans for ensuring that that is the case. Reverse DNS. Let's do some validation on what we found with the DNS server records before. Maybe there weren't any reverse records listed. Is that something we can abuse there? Port scanning. So much like Nmap, this offers a PowerShell variant of scanning through for open ports within the environment. NetView, similarly for enumerating more hosts from a domain, any shares accessible from that. And NetView actually has two pieces of it. It looks like it cut it off at the end there, or I didn't finish typing. But with NetView, you can actually look at a full set of shares that are read access only as well, meaning there may be a means of exfiltration just from that end. Mapping domain trusts. Are there any other domains that are accessible from this host environment you have access to? And then a plethora of get commandlets. These are just a few of them, but get computer, get domain controller, and get user, fairly self-explanatory, just getting details on those items relative to the environment. Get exploitable systems is interesting. This is an automated scripted get function where it will query those systems for known vulnerabilities based off the patch version. So some of you may have heard of the Eternal Blue Windows 10 exploits. That's one of the ones that it will be able to identify fairly quickly. And then lastly, get local group. Of course, is there anywhere in the local admin group you'd be able to try and manipulate, exploit this environment? So here, this is User Hunter and Stealth User Hunter. This is one where I did have access to a particular image, but you can kind of take a look and see what it's running here. So from Empire, within the Empire module, it's using its User Hunter module for then looking at, cool, what target users are on which hosts in this domain. What's scarier about this is that there's also a Stealth User Hunter method. If you were to run User Hunter, Windows, for the most part, will have the events recorded, and now at this point, security tools are strong enough for identifying, we're being scanned for our users. Stealth User Hunter essentially accomplishes the same. It may not give you as robust of a reporting, however, it will give you at least an endpoint and the host and a username without triggering the same events that the base User Hunter would trigger. Here's Share Finder. This is where you can enumerate all the shares available across any domain. And if there are trusts established, it will also go past that and look at what other shares are accessible from the host you're on. So, and as you can see, when you're running this, it gives you a full layout of what is accessible, meaning you now have a whole bunch of different endpoints you may look at scanning, continuing your enumeration efforts, and possibly looking at exploiting. This is where it gets perhaps the scariest, the privilege escalation pieces. PowerShell Empire has a lot of built-in native tools for allowing you to get higher privilege access into an environment such that you can run, maybe you want to make yourself a domain admin, you want to take over the environment fully. This is where the example here is running Invoke bypass UAC. So user account control, as we're aware in the Windows environment, does a fairly okay job of preventing unknown applications, unsigned applications from being run. This is something where after completing this, you will now give your user context, however running through an attack system, the ability to run, for the most part, anything as an admin or as a high integrity process. Actually, going back one, so I mentioned WScript UAC bypass as well. There's two pieces where you can just bypass UAC as it is, executing commands as a high integrity process. WScript, you can run now WScripts as a high integrity process. So meaning if you're more familiarized with running WScripts within a Windows environment from a DevOps perspective, that's another thing that could be exploited here. The lateral movement. So now that let's say the bad actor is in the environment and wants to explore it even further. Passing the hash, fairly common. A lot of you may have heard of Mimikatz. So this is one method of being able to steal your credential tokens and then passing that forward without having to know the details of that. Even crazier is Mimikatz have a few different modules underneath it that will let you decrypt those passwords so you can fully take those domain admins once you're on that environment. Going back to invoke WMI method and invoke PSExec. So these are standard PowerShell functions. However, these can be used by bad actors for running jobs remotely against systems. So WMI method, using it from a remote perspective, and PSExec more from the PowerShell perspective. These are common commandlets that you see run throughout DevOps depending on how an environment is being managed, especially for smaller environments. This being, and even legacy environments. This being the case, this is clearly something an attacker may want to take advantage of. Invoke PS remoting, just like PSExec and WMI method, allows for remote execution of PowerShell across the network. Those bottom three commandlets, those are native PowerShell commandlets. Those aren't anything special defined in Empire, but Empire is able to take advantage of these commandlets for running exploitation of an environment. So let's take a look at the lateral movements, particularly with passing the hash. So it's hard to see, maybe. You get Mimikatz running over here, and if you take a look, once it's running, it's able to find session, users, domain, logon servers, as well as full SIDs for those users. Even going further, it's able to break it down, finds NTLM and SHA-1 hashes. These are the same hashes that would be used for passing through. Within Mimikatz, you have something called creds, and what that will do is once it's pulled everything here, it will actually go through and decrypt because this has been found out. And as you can see, it's printing passwords in clear text, which is fairly scary considering you'd think Windows would be secure enough to prevent something like this. I will say that this is something that you can protect for in a Windows environment, but there's a lot of environments that are either not up to date, not running securely, or secure design wasn't, or it was an afterthought. So those would be environments where this would be a huge vulnerability. Another topic fairly important for the bad actors is persistence. You may have gotten onto the system, you may have delivered a payload onto the system. How do you ensure that you can continue exploring that system as a bad actor? And this is where PowerShell Empire has incorporated a few different modules that were developed outside of Empire. I don't know how much people are aware of Empire, but it's essentially a collection of tools that was gathered over a bit. So if you've heard of PowerSploit, PowerUp, the PowerShell Mafia, the PowerShell Mafia is another group that releases a variety of PowerShell modules that can be used for exploitation as well. And the Empire is essentially the huge collection of these modules put together. In persistence, you have something called Power Breach, and what this allows for is the use of memory backdoors. You have something called dead user. So let's say you want to use the presence of a user in an environment as a trigger. This is also going to be for 80 users the bad actor introduces into the environment. One of the reasons for why they might be doing this is they want to see how quickly will they be identified by the owners of that information system. So they'll put a dead user on there because the moment they see that dead user cleared away, they know that, all right, they have to start moving on to their next steps. So it's commonly used as a warning for and as a trigger, just in case they need to clear up their tracks. Event log, mainly for monitoring for failed RDP attempts, going back into the fact that if there are saved RDP event history, then bad actors can utilize that information knowing, cool, it'll be safe for me to attempt to sign in as this user and it wouldn't be seen as that suspicious by the environment. And then resolver. This is one where if you're looking at bouncing hosts on a regular basis, you'd be able to use that then also as another trigger. Userland, reboot persistence. I'm going to talk about userland and elevated, and actually debuggers kind of in the same context here. So userland and elevated, the biggest thing here is to maintain persistence from a cold start of the machine. So you can set scheduled tasks or registry keys. Registry keys are fairly easy to identify, especially by antiviruses. So modified registry keys, if that's the attempted method, you don't have that much time, maybe a minute or less nowadays, depending on how fast the environment is. Similar with elevated. Even in an elevated sense, it knows that, especially if it's trying to run anything through WMI, it'll find that to be suspicious activity, as that's not normal for most environments. This is where debuggers is interesting, because this allows for the same triggering of stages and persistence without any known user context nor admin privileges. So consider that prior to a login, there are certain tools and programs that are available at the start. Listed there, you get sticky keys, utility manager, on-screen magnifier, narrator, on-screen keyboard. These are common accessibility features within Windows environments. One of the things that can be done is that what these debuggers will do is trigger the start of one of these executables prior and use that as the signal for, let's insert this here prior to attempting any kind of a login. They may try to pass things in simultaneously, but it's a tool used for timing as a part of a kill chain. This is actually a slide from our previous presentation, but we were exploring PowerSploit a little. The PowerSploit functions can be used in conjunction with Empire, but also are accessible within So you get invoke mimikatz, as we were describing. You have the ability to dump clear text passwords from those credential tokens. Get keystrokes, get time screenshots, get microphone audio. Maybe you're looking at, the bad actors are looking at creating a Trojan of some sort. So not only logging keystrokes, logging screenshots with those keystrokes, and then if there's an accessible microphone audio component, to be able to do that without the user not realizing that. One of the pieces not listed here, there's also a webcam tool nowadays as well that's able to trigger that without the webcam light even going on. So you can see where this gets a little scary from the Trojan perspective. Set MBR, for whatever reason, if you feel like you need to replace the boot record. Nowadays, because MBRs aren't as common as they used to be, depending on your environment, I don't know how much value this has. However, it's still something you will find in legacy environments. And then set critical process. This is something where you want to crash your environment afterwards for essentially maximizing hiding the trail. So it's another piece that makes Empire just scarier than just a PowerShell module. And then just a common mentality. So this is, I'm borrowing this slide from previously, but I want to focus on this particular commandlet here, invoke enumerated local admin. If you take a look at how PowerShell Empire runs all of its modules, for the most part, they'll give you the full syntax, and I often find the get help associated with these modules a lot better than some of the native PowerShell get help modules. Part of this being Microsoft updates on, they don't update everything as a whole. It's only the relevant things are updated, so you'll always find outdated get help information. One of the things that makes this a little interesting is that the examples, it's not in the screenshot, but they actually give fairly useful examples for how it is you understand something's being run. Oh, and then this particular module was created by, or this commandlet was created by Harmjoy, one of the founders and creators of PowerShell Empire. So as you can see, when you are running this, all we're doing is running that against a defined computer name, something that was captured before. And take a look, it's dumping both the SID -500, meaning we can probably do something as the built-in account, local admin, and then no password expiry, meaning we may be able to reset the password on it. Same thing with password last set time. This may be an event that could be used as part of a kill chain by a bad actor. And then you'll know if it's disabled or not. User flags as well. Perhaps you're looking for the last time this was run through the event log, or you're trying to find, or the bad actor is trying to find their actions as a part of their kill chain. So it's something more identifiers for them to keep track of. And PowerShell being an amazing object-oriented scripting language, you can now carry these objects further through, pipe them, print them out, run them through full orchestrated processes so that something here where someone may be going through the research initially, you can have that be something executed within 10 minutes or so, assuming it's not too heavy. And that 10-minute number, fully variable. It depends on what it is you're trying to run, what kind of function it is. One of the interesting things about PowerSploit is this is something I typically run in an environment where I'm trying to look at what the vulnerabilities are, especially if you're looking at hardening operating systems within Windows. They have something called Invoke-AllChecks, and what this will do is that within a particular environment, to kind of explain what's happening here, this is running Invoke-AllChecks on the target machine itself. So it's looking for what kind of exploits are available. And then we take a look at what it's printing out. So one, it's found some Razor Wizard tool, a Razor Wizard service that can be exploited. What's really scary is what you see in this abuse function line. It's giving you potential means of exploiting that environment. So from the research end, this is one means of identifying how you can harden your operating system. Take a look at what Invoke-AllChecks is printing out for you, and then start scoping around what services it finds. If you're able to at least isolate those, because maybe, I know in this case this is going to be some gaming peripheral tool, but if this is a critical piece, a critical service that's needed, then from here, your next appropriate action would be, all right, let's secure this critical service such that it can't be exploited by other systems or other users or other user accounts. They also offer DLL hijacking. Yeah, so yeah, that's right. I probably won't repeat it on video, maybe. But to be able to hijack a DLL and use that because you know it's running under some standard context, and you're now able to use that for pivoting into another environment, taking over that environment, you can understand where it gets scarier because who knows what you can shove into that hijacked DLL. And then, as you can see too, Invoke-AllChecks will tell you what your appropriate, how it is you would go about abusing it. It won't run the full check on it, so if you try running this after, it may fail because this may be scoped already. It may be scoped in such a way that it can't be abused in a normal sense. And then PowerUp, another part of the PowerSploit module specific to privilege escalation. Take a look at all the commands that are within this module, and for the most part, nothing seems too crazy, especially from a DevOps perspective. This is huge for understanding how it is you'd want to harden an environment. But these are modules and commandlets that are accessible to bad actors as well. So consider what kind of information they can be armed with if they are able to pivot into your environment and have the module accessible to them. And I should say, getting a PowerShell module into a target system isn't that challenging. Invoke web expression should be strong enough if there aren't any antivirus checks looking for downloaded files. In the case that there are, you can actually download things into memory and run things out of memory, which is another scary piece of PowerShell, is the fact that it can run everything out of memory, meaning not leave a physical file footprint on the host machine. So now kind of actually before I move into Nishang, covered a lot of topics on Empire, but yeah, just questions or anything I could elaborate further on. I'm sorry that I don't have my live demo today. I built an AD environment, a standard AD environment, basic patching, where we were gonna run through Empire together, but my Windows VMs weren't booting up this morning, so part of the speaker's curse, I guess. However, I do want to rebuild it for continuing the series of these presentations. No one? So looking at Nishang, we're starting with some of the Nishang backdoors available. As you can see, you get an HTTP backdoor, so it means sending HTTP requests through DNS text, similarly doing that with DNS. Executing on time, so this is essentially running a scheduled backdoor for execution of PowerShell scripts, and then a registry backdoor. I mentioned earlier, any of the registry edits within Windows environments will be one of the more easily identified changes in a system, so more there just because it used to be a bit more prevalent. One of the other backdoors I like, or rather going into shells, Nishang has a variety of shells that can be invoked from your CNC, your attacking machine. So what's interesting there is that it's doing these through TCP, it's doing these through Telnet. It's got a variety of different methods of getting a shell established so that you can get open communication going with the target machine. Privilege escalation. Going back, we were looking at a lot of what PowerShell Empire is capable of, and now taking a look at Nishang, you get a lot of the similar functionality here. You get bypassing UAC, you get the ability to remove updates. This is something Empire I don't think natively has, but Windows PowerShell does. So consider that if you're able to build an Empire payload that includes removal of Windows features or Windows updates, that's another piece that makes Empire fairly scary along with PowerShell. And then duplicating tokens. If you're looking at more privilege escalation options, you want to act as a system. Going into the reconnaissance enumeration piece, check VM. If you suspect that you're in a VM virtualized environment, check VM will give you all the details you would need for identifying that. Most VMs under Windows context will have within their registries some registry key associated to one of the hypervisors, and makes it fairly easy for identifying. From there, once you get that information, you could probably go through and fully get your hypervisor hosts. You might be able to find additional details for compromising that environment. Copy VSS, the volume shadow copy service. As you can see, this will be where passwords can be accessible in the SAM. Credential phishing, and I've mentioned key logging earlier. So even Nishang utilizes Mimikatz and some of the other tools that PowerShell Empire will use for taking over an environment. This is PowerPritter. Not sure how you actually say that normally. But this is Nishang's attempt at creating something like Meterpreter, something that allows you to have all the functionality of Nishang accessible in a single module. So if you're able to get successful payload delivery, or the attacker is able to get a successful payload delivery, one of the things they may want to do into a Windows environment is to try to package up all of Nishang, because all those same tools, things I was described in the slides earlier, these would allow any would-be attacker for essentially pivoting, maintaining persistence, covering their tracks, doing everything they possibly could to take over a Windows environment. There are, and as I said earlier, there are plenty of protections against these things that could be implemented now, so not to present it as so scary that any Windows environment is weak or vulnerable to this, but it does mean that working in DevOps and for system hardening, understanding how these tools work is a clear piece for ensuring the security of the environment, because this will still continue to be improved upon, and it's keeping up with what the attackers are doing. That's how we're keeping Windows more secure as we go. But just kind of going into this, and this is, I don't know if you can see this clearly, but this is relating to persistence within the PowerPritter. So now that the PowerPritter payload is within the machine, you can see that you can have it check a URL. This will be, you can do a variety of things within that check, either use it as a trigger, use it for execution, payload URL. This lets the PowerPritter know where it is it should be pulling its payload. Any magic strings if there are anything in there, and then a stop string if you require it. There's actually a few more pieces within persistence that make this even scarier, but it makes it so that way the moment you're able to get this onto the host environment, it will try everything it can for making sure that it stays there as the attacker continues.
Before you go on, a question in the last slide.
Yeah.
www downgrade for ramps quick text credentials from Windows 8 and Server 2012.
Yeah.
So that obviously still works. You can still.
Yeah, so I mean, to just kind of take a look at the Windows environment as it stands now, Server 2019 was announced and it's slowly being rolled out into environments. Server 2016, I would say, is probably, it's more common, but 2012 and 2012 R2 are still fairly common Windows Server versions that are out there in the wild. And not really certain on, depending on who's maintaining it, that will inform how well is it being updated. So yes, this is still very much relevant to at least current attacking scene.
You're only kind of at a dead end if you're on Windows 10 or Server 2016, then this won't work.
This won't, there's a way to make it work, but it wouldn't be worth the effort. You'd have to manipulate a little bit further, and oh, actually no, you wouldn't do the dump with wdigest though. It's still possible to dump passwords with Mimikatz in Windows 10 and Server 2016. It just wouldn't be done through this method.
So you still clear text stuff from RAM?
You'd have to do the decryption, so you can still pull the hashes. The decryption you'd still have to set up manually, but you can actually use PowerShell for that, so you're not isolated to it. At the start, I showed my encoded commands. All of that I did within PowerShell. I didn't use any online tools for getting that encoding going. So decoding works in a similar capacity. The next piece of PowerPritter, I want to show just pivoting and how easy it is within PowerPritter. All it is calling pivot, point out a computer switch, point it to the computer, your login creds, and then do you want it, you have more switches available. Do you want interactive, non-interactive? So once Nishang enters into an environment, or at least through the PowerPritter package, you now have a means of traversing that environment, and you don't need to be full admin. As long as you do have some sort of RCE or some means of getting into the environment. From there, you can rely on the variety of tools within this, and this is what attackers play off of. I mentioned that you don't need to be a PowerShell expert to use these tools, and that's what makes this very scary, is that these are people just playing around, not knowing what they're doing and seeing what sticks and what doesn't stick. Going back into hardening an environment, it goes to show why due diligence needs to be performed from the DevOps perspective fairly heavily, because it's an awareness of these tools existing out there that allows us to better protect these environments. Then slowly wrapping up before we go into questions. Kind of going to the why offensive PowerShell, and when I'm asking this, it's not why use PowerShell offensively, but rather why is PowerShell used offensively by the bad actors out there? One, it's easily scalable and utilizes native Windows features for avoiding detection. Consider everything that was shown on how it is you could hide your tracks. You can change something to a standard event within Windows, something where it wouldn't be suspect by if there's a scanning tool that's looking for a particular action. PowerShell itself inherently isn't designed for malicious activity. This means that a lot of the native scanning tools out there will not look at PowerShell as that unusual, or especially if it sees PowerShell scripts running as it's a common part of most DevOps operations. It's highly accessible, flexible, and capable, just hammering on the points that PowerShell can be used in a variety of different ways. At such a level where I would never call myself a PowerShell expert, because I'm finding new things out on a regular basis. I'm using PowerShell in ways so differently now than how it was when I was first learning PowerShell, that it's not really fair to say. It's like with any language out there. You can't really call yourself an expert with it because it's constantly evolving, constantly changing. And then going into the quote, the famous quote that was often described, or that would often describe the British Empire, the empire on which the sun never sets. And for PowerShell, at least PowerShell used offensively, I don't, in this personal opinion, it's hard for me to say that it's going to disappear, at least from an offensive end, partly because of how prevalent it is in current DevOps solutions. The fact that Microsoft maintains PowerShell for its continued operations. PowerShell, we described it in our first talk, but they're now on .NET Core 2.0 framework, which allows PowerShell to run fairly OS agnostic. You can run this in Linux environments and Mac OS actually too. Going even further from that, it means that as long as PowerShell is continuing to be supported and grown in the way it has been, updating it without, while still preserving some of the legacy functionality, offensive PowerShell in this sense is going to be hard to really stomp out. And so it means for those of us working in the security end, we have to be made aware of how attackers are using PowerShell such that we know how to harden and protect against this. I mentioned throughout that we do have 2 more planned talks for this, so I want to thank DC206 and BLR for hosting us. If you guys are interested, our next talk would be my failed demo for today, where I was trying to run the AD environment, but we would run PowerShell Empire through a standard AD environment, maybe 4 nodes, nothing too crazy. And then our last talk would be the bonus talk on, we'll actually go under the hood, take a look at one of the PowerShell modules and explain how it is it's accomplishing what it's doing. I really want to go through one of the reverse shell commandlets, part of Nishang, the Invoke TCP reverse shell, how it is it's actually using TCP to get a shell back without using anything, and then how it passes PowerShell messages through. So sorry for the failed demo, guys, but any questions as we wrap up?
So putting on a blue team hat, how would you defend against this?
So this is, that's a great question. Putting on the blue team hat, and I treat it from the research end of it. Understand how the attackers are acting. So you will have to put on the red team hat prior to even putting on the blue team hat. Not as a red teamer, nor blue teamer, purple teamer. I'm a security consultant by trade, security enthusiast by day, and maybe play on Hack the Box by night. You've got a lot of different things that can happen there, and it would be, for me, I would look at from the attacker perspective, understand how these are going through, what are common things, consider advanced persistent threats that are out there now. A lot of them kind of have their own signature at this point for how it is they go about walking through the front door of an environment. So look at how it is they're accomplishing that. From there, use your human pattern recognition to see what's something that they're not considering in this, because oftentimes the solutions being used are fairly simple, because it's all about time and speed more than anything else. It's where you can build the strongest wall possible, but if all it takes is a huge sledgehammer to walk right through it, right? Was that
like one insider threat? That's actually the bigger concern.
exactly? Like, people are still the biggest concern, always at the end of the day. And this is where I personally think blue team has the hardest job, because blue team, to be effective as blue team, have to understand the red team mentality. And it's without knowing that attacker mentality, how do you know what to protect against, let alone how do you pursue the next offense? And does that kind of answer it?
Well, it's basically, yeah, you're screwed, and
Well, no, so I mean, kind of going back to why I chose when in doubt, run in circles, scream and shout. This is why I love PowerShell, where you have so much ability, but at the same time, it scares me even what it can do. I've done things on accident before, not knowing that's how you could gain entry into an environment. Take a look at some of the sysinternals tools, especially from a research end. Mark Rusinovich, that tool suite is a staple for at least me understanding services and processes inside of Windows. The fact that you can drill down through procmon to kind of see, oh, did they embed something weird here? This is, I will ramble on this topic for days, but it's at this point, it's so widely used in a variety of different ways. It's not something that can just be stamped out right now. If it's saying, let's go back to VB script, no, right? So let's stick with some of the more modern implementations. But it means that, and I think it's fair to say too, I don't know how many of you would agree, but a lot of the technical solutions we have currently kind of start out as a proof of concept, and without really being fully fleshed out, they get implemented. They look like they're working, so we don't change them. Take a look at TCP/IP. It wasn't really called IPv4 up until IPv6 started really being a thing, right? So things happen on accident, sort of, and as we try to progress, security right now is still a very reactive game, including in Windows as well. That being the case, a lot of this is, I think, informing the next strategies for how it is we protect against these in the future. It's understand the actors now, the bad actors now, to the best of our ability, and understanding how they're accomplishing things. From there, we can look at protecting against it, and then hopefully can start finally being proactive with security, because I don't think it's fair to say the proactive effort is happening now. We're getting there, though. We're definitely getting there.
I will say the new versions of PowerShell have a much better logging.
That sounds, yeah.
More lifespan. Yeah, that. Sure. But if you can prevent someone from downgrading to very old versions of PowerShell, then at least you can have insight into what they did.
Exactly. That's a clear event you can see happening and something you can attempt to prevent. This is one of the things where with Microsoft, they're applying Azure machine learning in a variety of different places. And one thing I'm really fascinated in is how they're using this to identify attack chains specific to APTs, those advanced persistent threats. They're able to use their machine learning for combing through large sets of events for now, honing in on, ooh, this looks like the signature of this APT. This looks like the signature of this group over here. How do we start preventing against this? And then I believe they're looking at establishing policies within those environments that make it so that.
Research in that area. Have you seen anything that actually works?
I know that I swear I'm not advertising for Microsoft here. Just it's the environment I know the best. They've just started the advanced threat protection teams across their entire infrastructure. So not just Azure, their whole Office team, and I believe even on the Windows OS end. And the big thing there is to now take what it is they understand about events like these that you would find in a Windows environment, use that to then establish protections against those advanced persistent threats, which I honestly think that's the kind of stuff we need to be doing more of in our security space. It's right now it's still strongly reactive. We have to place as many blocks as possible, because with those blocks in place, then we know what the next thing those bad actors are going to work on. put another block there. It's best to look at it as like if you got an exploded pipe, how many things can you shove into there to block that off fully? Doesn't stop the pressure from building up from eventually breaking through further, but you can do a lot to mitigate the damage and hopefully build a new pipe such that this is no longer a risk in the future. All right, any other questions?
Have you seen any research into escaping like constrained language mode?
No, this is, and actually, I want to kind of point out Matt here. I've read your Azure books, so from our previous PowerShell chat. No, and this is something that is a bigger concern because part of this is I still think red team has the easiest, relative to blue team, they have the easier thing. Their job is to break stuff down and find those holes in, and I don't have a solution, at least not yet, but I want to continue exploring security in this research capacity for ensuring that we can protect this stuff, because all of us here, I'd like to think we're strongly privacy-minded. We care about security. This is a huge concern because we have access to all these services and tools accessible online that we're essentially placing trust in those entities and groups to be mindful of this. And what's scary is that not everyone is fully mindful of this. And it's not due to ignorance or anything of that sort. It's to even know that this is something that exists out there. So this is the bigger piece and why I enjoy talking on this. It's essentially evangelizing such that we can help prevent this and maybe get more people interested in helping secure our future, at least with technology. Anyone? All right, I guess we're wrapping up. My name is Michael, everyone. Thank you, DC206 and BLR, for hosting. If you want me back, got maybe 2 more chats planned. So, and those ones I swear would be the fun ones where you actually see me click stuff and do things.
Barbecue